In this video, we will see numerical on biaxial stresses. Numerical is a plate 2 meter by 2 meter by 20 mm is subjected to stresses sigma x is equal to 100 MPa tensile and sigma y is equal to 50 MPa compressive. In the plane of plate, modulus of elasticity of the plate is 200 GPa and Poisson's ratio is 0.25. Calculate the change in volume of the plate. First write given data. Length of that plate is same as breadth of that plate 2 meter and in mm 2000 mm. This is length of plate and this is breadth of plate and thickness of that plate is 20 mm. Stresses sigma x is tensile stress. Tensile stress is positive 100 MPa and stress sigma y is acting compressive and compressive stress is negative minus 50 MPa and MPa is equivalent to 1 MPa is equal to 1 Newton per mm square. Modulus of elasticity of plate is 200 gigapascal. Modulus of elasticity capital E is equal to 200 gigapascal and convert this gigapascal into megapascal. Multiply it by 10 raised to 3 megapascal. Poisson's ratio is 0.25. Calculate the change in volume of the plate. To find change in volume of that plate subjected to biaxial stresses. For finding change in volume of that plate, we need strain in x direction, strain in y direction and strain in z direction. So calculate. Strain in x direction denoted as Ex. Ex is equal to 1 upon modulus of elasticity in bracket stress in x direction minus mu into stress in y direction. 1 upon Young's modulus is 200 into 10 raised to 3. Stress in x direction is 100 minus Poisson's ratio is 0.25 into stress in y direction is minus 50. So strain in x direction is, calculate 0.25 into minus 50, 100 minus divided by 200 into 10 raised to 3. 5.625 into 10 raised to minus 4. Strain have no unit and strain in x direction for that plate is 5.625 into 10 raised to minus 4. Next, calculate strain in y direction. Ey. Strain in y direction formula is 1 upon Young's modulus into stress in y direction minus Poisson's ratio into stress in x direction. Young's modulus is 200 into 10 raised to 3. Stress in y direction 50 minus 50 minus 50 minus Poisson's ratio is 0.25 into tensile stress in x direction is 100. Calculate. Minus 3.75 into 10 raised to minus 4. Next, calculate strain in z direction. Formula for strain in z direction is 1 upon Young's modulus multiplied by minus mu into sigma x minus mu into sigma y. 1 upon 200 into 10 raised to 3 is Young's modulus minus, take common this mu minus sigma x minus sigma y. Mu is 0.25 upon 200 into 10 raised to 3. Tensile stress in x direction is 100 and minus strain in y direction. Stress in y direction is minus 50. Oh, minus 100 plus 50 into 0.25 upon 200 into 10 raised to 3 minus 6.25 into 10 raised to minus 5. Now calculate total strain for that plate. Total strain for that plate is strain in x direction plus strain in y direction plus strain in z direction. Strain in x direction is 5.625 into 10 raised to minus 4 plus strain in y direction is minus 3.75 into 10 raised to minus 4 plus strain in z direction is minus 6.25 into 10 raised to minus 5 total volumetric strain is 5.625 into 10 raised to minus 4 plus minus 3.75 into 10 raised to minus 4 plus minus 6.725 into 10 raised to minus 5. 1.25 into 10 raised to minus 4. This is total volumetric strain minus, so total volumetric strain is 1.25 into 10 raised to minus 4 Volumetric strain is nothing but the change in volume to the original volume equal to 1.25 into 10 raised to minus 4. So this volumetric change in volume is equal to 1.25 into 10 raised to minus 4 into original volume of that plate. Original volume of that plate is length of plate 2000 mm, breadth of plate 2000 mm, thickness of plate 20 mm, and original volume for that plate is L into B into T. 2000 into breadth is 2000 into thickness is 20. So change in volume comes 1.25 into 10 raised to minus 4 into 2000 into 2000 into 20. 10,000. And volume in it is mm cube. For that plate of length 2000 mm, breadth 2000 mm and thickness 20 mm and tensile stress in x direction is 100 Newton per mm square and compressive stress in y direction is 50 Newton per mm square. Change in volume is 10,000 mm cube. Alternative method and short method for solving this numerical is change in volume is equal to volumetric strain multiplied by volume, and volumetric strain formula is stress in x direction plus stress in y direction upon Young's modulus 1 minus 2 mu multiplied by v. And directly from given data, we know that tensile stress in x direction is 100, compressive stress in y direction is minus 50 upon modulus of elasticity is 200 into 10 raised to 3, 1 minus 2 into Poisson's ratio is 0.25. All given data is in numerical into volume of that original plate is 2000 multiplied by 2000 multiplied by 20. Change in volume 100 minus 50 upon 200 into 10 raised to 3 into 1 minus 2 into 0.5 into 2000 into 2000 into 20. 10,000 mm cube. This is short method for solving this numerical. Use direct formula and solve this numerical. Thank you very much.